Hello everyone, this is the question asked in GATE 2019 Electrical Engineering. It takes 2 hours for a person X to mow the lawn. Y can mow the same lawn in 4 hours. How long will it take for X and Y if they work together to mow the lawn? So we have been given with two persons X and Y whose individual contributions and individual time to mow the lawn has been given, and we have to determine how long will it take for them if they work together. Now, in order to solve this problem, let's have a look at the useful data. So, the first thing in such type of questions that we need to calculate is the work from days. That is, if a person X can do a particular work in n days, then that person's 1 day work would be equal to 1 upon n. And similarly, if a person's 1 day work is equal to 1 upon n, then that person can finish the work in n days. That would be basically the reciprocal of it. Therefore, the number of days can be found out by dividing the total work that needs to be done divided by the work done in 1 day. So let's use this concept and try to solve the problem. So this problem can be solved by two different ways. The first one is the algebraical way, which is straightforward, and the second one is a geometrical way, which would give a better visualization of how things are working. So let's first solve the problem by a simple algebra. So it is given that X can complete the total work in 2 hours, which means that X 1 hour work would be 1 upon 2 units, and here the total work done is 1 unit. So X 1 hour contribution would be 1 upon 2 units of the total work. Similarly, Y can do the work in 4 hours. Therefore, Y's 1 hour work would be 1 upon 4 units. Now, if they both work together, then X and Y's 1 hour work would be given by 1 upon 2 plus 1 upon 4. That is 3 upon 4. So, in 1 hour, X and Y can do 3 upon 4 units of work. Therefore, the total time taken by X and Y to complete 1 unit of work would be given by the total work that needs to be done, which is 1 unit, divided by the total work done in 1 hour, which is 3 upon 4 units. And this would give me 4 upon 3 hours. So this is the total work done by X and Y if they both work simultaneously. And we have to find that answer in minutes. So we multiply the hours by 60 to get the final answer, which is 80 minutes. Now, this was the first approach to solve the problem. Now let's have a look at the second approach, which is the geometrical approach to solve this question. So imagine that the person X works uniformly to complete the work W, and it takes him T1 time to finish the job. Similarly, the person Y works uniformly to complete the work in T2 time. Now, if they both are working together, then it is well known that the time taken would be less than T1 and the time taken would be less than T2. So I'll do a trick here and flip this triangle to obtain a figure something like this. So in this figure, the only thing that has been changed is that the triangle of Y has been flipped. So that means that the person Y is starting the work from the end and the person X is starting the work from the beginning. So at one point they are going to intersect, by which the total work has been completed, and this is going to take T time. So this problem now has been boiled down to simply two triangles, and in between them there is an intersection, and I have to determine what this T time is, given that the work done by both these entities is W and the individual time taken are T2 and T1. So let's try to solve this problem. So let's first name the triangles. Now we can observe that triangle ABC and triangle FGC are similar, since they have a common angle between them and they have a 90-degree angle with them, which means that their sides are proportional. That is, W upon Fg would be equal to the time taken T2 upon T2 minus T. Also, we can see that triangle EBD would be similar to triangle FPG. That is, triangle EBD and triangle FPG are similar. Therefore, W upon Fg would be equal to T1 upon T. Now, if I substitute the value of W upon Fg, then I would have an equation something like this. And on solving for T, I would get the value as this. So, the final value of T would be equals to T1 times T2 divided by T1 plus T2, which is the weighted mean for the time. Hence, in such type of problems, if I have an entity who takes T1 time to do that work and a different entity who takes T2 time to do the same work, then the time taken by both the entities if they work together would be T1 times T2 divided by T1 plus T2. So, in this context, it would be 2 hours times 4 hours divided by 2 plus 4 hours, which would be 4 upon 3 hours, which is 80 minutes. Hence, option B, 80 is the right answer. Also, in such type of problems, we don't actually need to solve given equations. If we have an individual entities who takes T1 days or T2 days and so on, then in order to determine the time taken if they all started working together would be given by 1 upon T equals to 1 upon T1 plus 1 upon T2 and so on, and then we can find the value for T. Thank you.